Hello students, today we are going to discuss about magnetic force between two current carrying parallel conductors. Okay, so here we have two parallel conductors. Okay, so there are two cases. First is light currents and unlight currents. So light current means what? When current are in the conductor are both are in the same direction. Okay, so those are called as light currents, and when one conductor having opposite direction to that other, at that time that condition is called as unlight currents. Okay, so magnetic field is due to first conductor on second conductor is B1, and magnetic field due to second conductor on first conductor is B2. Okay, so we have to write these fields. We have studied earlier from the Ampere circular law as well as Bart-Savart law. According to that, for a long straight current carrying conductor perform a field like this. Okay, so after solving this, we have got the B1 is equal to mu 0 I1 upon 2 pi d. So distance between them is d. That's why we have to take this distance. Okay, same for this. Okay, so this is the uniform magnetic field due to current carrying conductor I1 on conductor which carry current I2. Okay, so second, what we have, field B2 which is equal to mu 0 I2 upon 2 pi d, same like that. Okay, and that uniform field is due to current carrying conductor I2 on conductor I1. Okay, so here we have find the force. So here we have considered a small current carrying element which is real. So force due to that on second conductor is on first conductor is what, dF12 is equal to B2 I1 dF. Okay, and due to this on this is what, dF21 is equal to B1 I2 dL. Okay, so I will find this force. So force, according to this, we have the value of B1 and B2. We have to put these values in our equation first and second, and we have got the forces for smallest element, and then we have to find the magnetic force per unit length on each element. Means this dl goes to divide. Okay, so each conductor having same kind of force, or each conductor having same kind of magnetic force per unit length, and we have to set it as a F, and small f is equal to mu 0 I1 I2 2 pi d. So unit, SI unit of this is what? This is what? Force per unit length. That's why Newton per meter, or CGS is dyne per centimeter. Okay, so magnetic force on the conductor. So this is we have to study about smallest element for the current carrying conductor. So if current carrying conductor having length L, so we have to multiply small f by L, and we have the equation. Magnetic force on current carrying conductor is what? Mu 0 I1 I2 upon 2 pi d into L. Okay, so this is all about magnetic force between two current carrying parallel conductors. Okay, same we are studying two cases here for the same condition, which are those: equilibrium of free wire. We have studied about equilibrium of free wire. So what is mean that? Equilibrium of free wire. Okay, so equilibrium of free wire. So case first is upper wire is free. Case first. In that case first, upper wire is free. Okay, so upper wire is free. At that time, what should we have? In that case, we have two wires. Here is the lower wire. Okay, and here is the upper wire, which is free wire. Upper wire is freely suspended. Okay, and in our wire, what will happens? Here current I1 is occur, and in this I2 is okay. This wire is fixed So force, this is a downward force act on this wire. So wire consider having the mass m, so the force Fm, which is gravitational force, acts on this wire. Okay, but here is another force which is acts on this wire, is what? Fm means magnetic, sorry, we have to say it as a F, means magnetic force. And earlier we have studied that magnetic force is equal to what? So from the above equation, earlier equation, what should we have? Magnetic force per unit length. So magnetic force per unit length, and the height between these two is h. So magnetic force per unit length. So magnetic force per unit length is what? We know that F is equal to, mu 0 I1 I2 upon 2 pi h. So this is the magnetic force. After that, what should we have? In a balanced condition, F is equal to Fm, because both are in the balanced condition. In balance condition means both wire are in equilibrium. So F is what? Mu 0 I1 I2 upon 2 pi h. And gravitational force per unit length means what? M upon L into G, means gravitational force per unit length. So at that time, this wire is in equilibrium. If free wire is slightly displaced, then it executes in the SHM. Free wire is slightly displaced, then it executes simple harmonic motion. To and fro means simple harmonic motion. So it is like this, move like this in simple harmonic motion. So at that time, it having some time period of oscillation. So that time period of oscillation is given by, according to the simple harmonic oscillation, T is equal to 2 pi under root of h upon g, means L upon g or h upon g, like this. So this is the time period of oscillation. Okay. Second case, if lower wire is free. At that time, what happens? If lower wire is free or in equilibrium, condition is like this. Upper wire is fixed, which having current I1, and lower wire is freely movable, which having current I2. Distance between them is h. So same thing here. What happens? So here we have magnetic force per unit length due to free wire is Fm, sorry, F, we have to say F, or we have to say Fm is equal to mu0 I1 I2 upon 2 pi h, and weight of this upper wire is W, which is what? mg upon L, means gravitational force per unit length. So in balance condition, what happens? Fm is equal to W, means mu0 I1 I2 upon 2 pi h is equal to m upon L into g. So this is all about magnetic force due to two current carrying parallel conductors. After that, we are studying about our exercise first. Okay, तर मी तुम्हाला 1 to 50 क्वेश्चन सॉल्व करायला सांगितले होते एक्सरसाइज फर्स्ट मध्ये. सो दिस इज द एक्सरसाइज फर्स्ट. तर सगळ्यांना हे मॉड्यूल जे आहे ते उपलब्ध झालेले आहेत PDF स्वरूपात. सो फर्स्ट क्वेश्चन तुमच्या समोर असेल PDF स्वरूपात. तर फर्स्ट क्वेश्चन आहे, a stationary magnet does not interact with. So first question is, stationary magnet does not interact with. ओके, तिथे त्या प्रॉब्लेम मध्ये चार ऑप्शन दिलेत, आयर्न रॉड, मूविंग चार्ज, मूविंग मॅग्नेट अँड स्टेशनरी चार्ज. आता बघा त्यांनी म्हटलंय की स्टेशनरी मॅग्नेट डज नॉट इंटरॅक्ट विथ. कोणासोबत इंटरॅक्ट नाही होणार, तो इंटरॅक्ट कोणासोबत होईल हा विचार करावा लागेल पहिला. इंटरॅक्ट कोणासोबत होतो मॅग्नेट, की ज्या मॅग्नेट तो दुसरी जी ऑब्जेक्ट आहे ते पण काय असलं पाहिजे, मॅग्नेटिक प्रॉपर्टी होल्ड करणारं पाहिजे. आयर्न रॉड आहे, आयर्न रॉडमध्ये मॅग्नेटिक प्रॉपर्टी असतात. ओके, देन मूविंग चार्ज, म्हणजे एखाद्या ऑब्जेक्टमध्ये मूविंग चार्ज असेल तर त्या ठिकाणी पण मॅग्नेटिक फील्ड प्रोड्यूस होते. त्यानंतर मूविंग मॅग्नेट, मॅग्नेट आहे म्हटलं त्याच्यात मॅग्नेटिक प्रॉपर्टी येणार आहे. ह्या सगळ्यांसोबत हा स्टेशनरी मॅग्नेट काय होईल, इंटरॅक्ट होईल. राहिला फक्त काय, स्टेशनरी चार्ज. स्टेशनरी चार्ज मॅग्नेटिक फील्ड प्रोड्यूस करत नाही. सो दॅट्स वाय फॉर फर्स्ट क्वेश्चन आवर आन्सर इज स्टेशनरी चार्ज. कारण हा कुठल्याही प्रकारचे मॅग्नेटिक फील्ड प्रोड्यूस करणार नाही. ज्यावेळेस स्टेशनरी चार्ज मूव्ह व्हायला सुरुवात होतो त्याच वेळेस त्या ठिकाणी मॅग्नेटिक फील्ड काय होते, प्रोड्यूस होते. ओके, सेकंड मी क्वेश्चन लिहित नाही आहे, फक्त आन्सर डिस्कस करू. फॉलोइंग इज स्क्वेअर शेप लूप whose one arm BC produces a magnetic field B at the center of coil. The resultant magnetic field due to the all arms will be. So here are square loop. Okay, like this. Each arm having same current. That means it produces same field, and we have to find the field at this center. Okay, or at point O. So the net field is what? B net is equal to B1 plus B2 plus B3 plus B4, because all of the wires are producing the fields. Okay, because length and carrying conductor is same, so that's why it produces the same field, and which is what? So like this, like this, like this. It all produce same field at that point. So we have considered this field as B. So B plus B plus B plus B, which means net field is 4B. Okay. Then after that, number third, a wire is parallel to one arm of square current carrying loop, which is also carries current. Now at any point A within the coil, the magnetic field will be so in this condition, interaction between these two, it reduces the effect of this field to this. Okay, so as compared to square, the field is less than when we have put this wire. So option number is first. Okay, after that we have question number 4. In the question number 4, what did they say? A current of 10 ampere is established along a wire of positive z direction. So we have considered here, suppose z, y and x. So this is the conductor put along which having 10 ampere current. Okay, and the magnetic field at the point. So magnetic field produced along this x point is 1 meter from distance. Sorry, B. We have to find that. Okay, so how we find that field? So for that, what should we have? For a circular straight current carrying conductor, B is equal to mu 0 I upon 2 pi r. Mu 0 I upon 2 pi r. Okay, so mu 0 is equal to 4 pi into 10 raised to minus 7 Weber per meter. Okay, so 4 pi into 10 raised to minus 7 I is 10 upon 2 pi into 1, because the distance is 1 meter from the conductor. Okay, so pi get cancelled, 2. Okay, so 10 into 10 raised to minus 7 it means 2 into 10 raised to minus 6. So 2 micro Tesla. Okay, so this is the value. How we find the direction? As we know that we have to find the field, and field is the given by length of element and direction of field. So dl bar cross r bar. Direction of field is given by dl bar cross r bar, and dl is along the z direction, means k cap cross r is along x direction of field. So this is I cap. So k cap cross I cap is j cap. So hence 2 micro Tesla along the positive y-axis. Why positive y-axis? Because j cap represents the positive y-axis. Okay. Then the fifth question. So how we discuss the fifth question? So in the fifth question, what should we have? Radius of current carrying coil R, then the ratio of magnetic field at the center of the coil to the axial point, which is R under root 3, distance away from the center of the coil. So we have tried to formula first. At the center for a current carrying coil is what? Mu 0 I upon 2R. And at the axis it is what? Mu 0 I r square upon 2 r square plus x square raised to 3 by 2. So here is small r is equal to capital R and x is equal to r into root 3. Small r is equal to capital R. So how we solve? BC is equal to mu 0 I upon 2r. This is the equation first. Okay, this is the equation first, and after that what should we have? B axis. So if we add the axis is mu 0 I r square upon 2 into s r square plus 3r square raised to 3 by 2. Okay, how we solve? Mu 0 I r square upon 2 4r square raised to 3 by 2. So first we are taking square root. It makes simple to us. I r square upon 2 and square root of this is what? 2r cube. So after solving this, what we have got? Mu 0 I r square upon 2 cube of 2 is 8. 2 is 16 r cube. So r get cancelled. So b axis is equal to mu 0 I upon 16r. So PC to B axis is what? Mu 0 I upon 2r upon mu 0 I upon 16r. Mu 0 get cancelled, r get cancelled. 16 upon 2 means 8 as 1. So D option is correct. Answer is D option. Okay. So next problems we have to discuss in our next video. Thank you.